Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to electricity and magnetism. Previously we discussed questions on electric dipole parameters. So in the next series of videos we will be discussing some more questions on electric potential. So electric potential energy, work done in moving a charge in electrostatic field, and all those related things. Electric potential due to dipole, related to all that we'll be discussing questions. So the theoretical discussions we have already covered, so please check the electricity and magnetism playlist for videos on the theoretical concepts, formulas related to electric potential. So this is the first question. It is given to find the electric potential at the surface of an atomic nucleus having atomic number equal to 50 and having a radius of 9 into 10 to the power minus 13 centimeter. Okay, so here basically the concept is that we are considering a nucleus. Okay, so all the charge, it is assumed that it is centered around this point. Okay, all the positive charge. Nucleus consisting of protons and neutrons. Neutrons are neutral and protons, they have a charge of plus 1.6 into 10 to the power minus 19 coulomb. There are total of 50 protons, same number of protons, same number of electrons. So this total charge of this atomic nucleus, that is equal to 50 into 1.6 into 10 to the power minus 19 coulomb. Okay, this is the thing. Now we know that we have to calculate this potential at the surface of the nucleus. We have to calculate the potential at the surface. So when we have to calculate it at the surface, we have to consider this radius. Okay, the radius of the nucleus, which is equal to 9 into 10 to the power minus 13 centimeters. Now we know the formula for electric potential at any point due to a charge. Okay, so let us say we have a charge here Q and we have to find the electric potential at this point, okay, P, due to this charge, which is at a distance of R away from it. So the formula of electric potential at the point P is equal to 1 by 4 pi epsilon 0 Q by R. This is the formula. So here we will be doing that. Here the total charge, that is equal to this, because of the atomic nucleus, positive charge. The potential at the surface we have to calculate. So we have to consider this as the separation distance R, the radius of the nucleus. So it will be the potential at the surface, okay, at this point, that is equal to 1 by 4 pi epsilon 0 total atomic nucleus charge by radius of the nucleus. Let's call it Rn, okay, radius of the nucleus, equal to this 1 by 4 pi epsilon 0 part, that is equal to 9 into 10 to the power 9. This total charge, that is equal to 50 into 1.6 into 10 to the power minus 19 coulomb. Radius of the nucleus, that is 9 into 10 to the power minus 13 centimeters, so that is 10 to the power minus 15 meters, converting into MKS units. So the result that is coming, it is equal to 8 into 10 to the power 6 volt. Okay, that is the result, 8 into 10 to the power 6 volt. That is the answer. So here is another question on electric potential. So here it is given that the potential at a point 0.1 meter away from an isolated point charge is 100 volt. We have to find the nature and magnitude of the point charge. So here the question is, the situation is that we have an isolated point charge, okay, and at a distance of 0.1 meters from it, the electric potential at this point is equal to 100 volt. Let's say this point charge, isolated point charge, is Q. Now we know, and this is the distance, separation distance, R. Now we know that electric potential at any point is given by 1 by 4 pi epsilon 0. Epsilon 0 only because nothing has been mentioned whether the charge is placed in any other medium. So we have to assume it's free space or air. So epsilon r, relative permittivity, is 1. So that is equal to Q by R, the gap. So here it is given the voltage is 100. This is 9 into 10 to the power 9, 1 by 4 pi epsilon 0. Q by 0.1. We have to find Q. That implies Q is equal to 100 into 0.1 by 9 into 10 to the power 9. So it is coming, so it's plus 1.1 into 10 to the power minus 9 coulomb, or 1.1 nano that. Okay, so very simple and straightforward. This is the solution. So here is another question on electric potential. So here it is given, find the electric field between two metal plates which are separated 3 mm apart and connected to a 12 volt battery. So basically here we have two metal plates which are connected to a 12 volt battery. Okay, and the separation distance is 3 millimeters. Okay, this. So we have to find the electric field between these two plates, plate 1 and plate 2. So here we know that electric field is electric potential or potential difference between 2 points divided by the separation distance. Okay, and here that's why when we use the unit of electric field, we use Newton per coulomb or volt per meter. These two units can be used to represent electric field. So here the potential difference is 12 volt and the separation gap is 3 millimeter, which is 3 into 10 to the power minus 3 meters, okay, in MKS units. So it is 4 into 10 to the power 3 volt per meters. Okay, that is the electric field between plates 1 and 2 here. Okay, so very simple and straightforward.